Everybody, Harold here. Today I want to talk to you about string methods and parsing in polars. So in Google Colab again, import polars as PL and from rich import print. Create a small data frame here. Tools, hammer with a emoji, saw, wrench, and screwdriver. Want to print that? There you go. Hammer with emoji, saw, wrench, and screwdriver. One string method you can use is define the length of bytes and the length of characters. So get the length in bytes and characters of each tool. I'm going to say for this result, it goes df.withColumns. All this parentheses, pl.call tools. The string methods are all dot string dot len bytes, length in bytes of the string, and then we'll give that an alias for that column called byte count. And we'll add one more column. pl.call tools dot string dot len chars, and that's length in characters. And we'll alias that as char count, and then we will just print result. So screwdriver, wrench, saw all have the same bytes as characters. Hammer says there's 6 letters in hammer and an emoji. That's 7. But some characters, like emojis and foreign language characters, like stuff with umlauts and tildes, take up more space in the bytes. So that is why the byte count on hammer is 10. It's because I have that emoji in there. It takes up 3 bytes. We do some pattern matching. Some simple ones are starts with, contains, and ends with. So results equals df.select, and let's start with our original tool column. Then we'll add field.go tools dot start with. I'm sorry, all string methods start string dot starts with, and we'll say ham. And we could say pl.call tools dot string dot contains inch and pl.call tools dot string dot ends with. Let's say driver. Let's give those alias. And see what we get. Let's print result. So hammer starts with ham is true. String contains inch, wrench. String contains inch, true. Screwdriver, string ends with driver, true. So those are Boolean to check whether the pattern is there or not. Some other string methods I've created I'm a Seinfeld fan. I've created by the way, a small data frame here called words. George likes his chicken spicy. I've mixed the cases up. So it looks like this. Um, so I'm going to show you the case changes in zfill string method. So result equals words dot with columns. The whole data frame, we're going to add these columns. Field.call word dot string dot to underscore lowercase and dot alias lower. Let's copy this one twice. And let's say upper and upper. And title. And title. And the last one I wanted to show you was zfill. If they're not 10 characters long, this will fill the rest of it with zeros. I'll give that an alias of zfill. So let me show you that. So let's print result. So all lowercase George likes his chicken spicy. All uppercase George likes his chicken spicy. Title case George likes his chicken spicy. And padded with zeros to make him length 10. George likes his chicken spicy. Another string method, not commonly used, but it's kind of cool, explode. So this data frame is spicy, chicken, and anti-dentites. So let's just print test strings of spicy chicken and anti-dentite. Just string spicy chicken anti-dentite. Now to explode it, I could say print test dot select pl dot call a dot string dot explode. And what this does is creates a one column data frame of all the characters in that column. Spicy chicken anti-dentite. It's deprecated. Use string got split dot explode instead. That that's just showing you explode. If you want to pad strings with extra characters, I'd say results, kind of make it look nice, equals test with columns, dot call a dot string dot pad start. Let's from the start and make everything 11 characters long. And if they're not, put asterisks in front of them. Then we'll dot alias added, and then we'll print result. So that kind of evens it out, pads it, right aligns it. Replace, turn the word chicken into Chicago. So result equals test dot with columns, dot call a dot string dot replace. Take out kin, put in ago. And we'll give that an alias of replaced, and we'll print that result. So spicy chicken anti-dentite, spicy Chicago anti-dentite. Replaced kin with ago. Reverse the strings in column A of test. Well, there's a method called reverse. So result equals test dot with columns. Dot column A dot string dot reverse dot alias. We'll call that backwards. Print result. Spicy chicken anti-dentite. So slicing, you can do that. Take a slice of the fourth and fifth letters in the string and of each word in the column. So we'll just print this test dot select. I'm going to select A, and then we're going to call substring equals pl dot call A dot string dot slice. Start at the index 3, which is the fourth character, and a length of 2 characters. And we'll just run that cell. It's CY, CK, ID, the fourth and fifth letters in each string. There's a couple other methods, strip prefix and suffix. So strip characters from the beginning of a string. I want to take CHI off Chicago. I'm going to just print test dot select pl dot call a dot string dot strip prefix from the beginning chi, and we'll give that an alias of strip chi. So CKEN, took Ken off. Let me just copy this. And we're going to strip suffix. We're going to strip height. Call it strip height off anti-dentite, because that's the suffix. The end. And anti-dent. And then I'll show you extract. So Got a small data frame here, product codes. Run that, show it to you. What I want to do is take the numbers out of ID. To do that, you can use regex. So you would say, and I'm not going to get into a bunch of regex because I don't really like it that much, but people want to, you need to do it, but whenever I do it, I just Google how to do it. I don't remember all these patterns. Result equals product codes dot with columns pl.col item description dot string dot extract. I keep putting slashes for dots. Sorry. And when you do regex, you say R, what you're looking for, any numbers, one or more digits after ID. That's what that means. And let's give it an alias of extracted ID. And then we'll print result. So it took 1, 2, 3, 4, 5, 6, and those two didn't have any, so it returned a null if it's not there. Last but not least, I want to show you how to parse date and time strings. So I have a little df called clock. I love how rich prints times. I like that green. But there it is. To format time as time. Let's just say print clock dot with column pl.col time. And you're not casting, you're parsing strings. So string dot string parse time pl dot time and your format hour colon minute. And we'll call that the alias formatted. And with that, I did something wrong. I'm sorry, your formats have to be in quotes. So time is a string, formatted is a time, and it's formatted, it's got hours, minutes, and seconds. And for dates, so calendar expl data frame, that's the string of dates, formatted as a date. I'd say print calendar dot with columns pl dot call date. I guess lowercase date or lowercase date dot string parse time pl dot date comma in quotes, %y dash %month dash %day. Again, this is something I always look up too. Don't try to remember all these. And let's give that an alias to format it also. And now we have a date string column, but correctly formatted as a date type column. So that is it for string methods and parsing strings. I hope you liked this video. If you did, please like it, subscribe, and I'll see you next time. Thanks, everybody.